Very good morning. Welcome back to the session. And this is Dr. C. Raghavendra, Associate Professor, Institute of Aeronautical Engineering, Hyderabad. So today we'll discuss about an interesting topic called transmission medium. Transmission medium plays a very important role. Here we can understand what are the various transmission mediums are available, how the data or signals are going to be transmitted from one place to another place. So what are the basic path is going to be taken place. So how it is going to be transferred, what are the ranges, okay, which type of what are the various types of transmission techniques. All these things can comes under this session, and let's see what is exactly is going to be taking place. Transmission medium. For any networking to be effective, stream of data is to be transported from one device to other device over some medium, isn't it? So how it is going to be, data is going to be transferred from one place to another place only with the help of some transmission medium. For example, so there are two persons, okay, there are two persons are communicating with each other, okay, to speaking to each other, okay, both are speaking each other and transmitting their ideas, okay. Then how it is possible, what is the transmission medium here? Here the transmission medium is air, isn't it? So if two persons are directly communicating with each other, the transmission medium is air, okay. If assume that if the system, two systems are communicating with each other means, so what are the various transmission mediums are available, okay, those things we are going to discuss. Various transmission medium can be used for transfer the data, right? There are so many transmission mediums are available to transfer the data, and there are two types of transmission media, okay. Not we are going to telling about the techniques. There are two types of transmission media is there. One is guided transmission, another one is unguided transmission, okay. So this is the broad categorization. There are two broad categorization of transmission media. One is guided, another one is unguided transmission media. So this is a broad classification, exactly in depth of again how those two are going to be subdivided into each other. So if you take this transmission medium, this is a guided and this will be the unguided. Again, guided and unguided again subdivided into three types. So in this guided, there is a one particular technique called twisted pair cable, and another one is coaxial cable, another one is optical fiber cable. There are three different types of cables we are using for transmitting the data from source to destination, okay. One is twisted pair, coaxial cable, and optical fiber. And next, coming to the unguided media, whereas here the data can be transferred from one system to another system with the help of radio waves, microwaves, and infrared, okay. Radio waves, microwaves, and infrared, okay. We will see each and every technique under guided as well as unguided, okay. First we'll see the guided transmission medium. So it also referred as a wide or bounded transmission medium, okay. You please remember the terminology. This guided transmission medium, we can also call it as wide transmission medium or bounded transmission medium, okay. Both are same, okay. Sometimes when they are going to give a tricky, that means they are going to ask you that so what are the various types of bounded transmission medium, or we can say that what are the various types of wired transmission medium, like that they may ask the question like this, okay. You please remember both are wired and bounded, both are the same, right? Both are comes under guided transmission medium. In guided transmission media, transmitted the data travels through cabling system that has a fixed path, isn't it? So there is a dedicated path from source to destination system is already established. Only with this dedicated path only the data is going to be travel from one place to another place, isn't it? And what are the features of guided transmission? So it has a very high speed data transmission and secure data transmission used for comparatively shorter distance, right? So this is very similarly like so in the circuit switching, okay. Circuit switching is the best example. So in the circuit switching, so we are using this guided medium, right? So in circuit switching, we are using guided media. So here the path will be established in the earlier. So there are some best features of high speed and very secure, and comparatively it after the shortest path among several routes, right? So each transmission media has its own advantages and disadvantages in terms of bandwidth, speed, delay, cost per bit, ease of installation and maintenance, etc. Isn't it? So we have several methods out there, isn't it? Whether in guided or unguided. So if you can take anything, so every particular type of technique having their its own advantages and disadvantages. Okay, so based on the user requirements, the user is going to opt which type of method need to implement for data transfer from source to destination across the network, right? So in this, okay, the requirements I said, no, user requirements. There are so many user requirements. Those are broadly classified like maybe bandwidth, speed, delay, cost per bit, ease of installation, maintenance. By whichever the options they are going to, user is going to prioritize based on this, they are going to opt the specific method or specific type of data transmission is going to be implemented. Okay, so let's discuss the three major types of guided media, that is a twisted pair, coaxial cable, and finally optical fiber. We'll see what is twisted pair, coaxial cable, optical fiber, what are the advantages, disadvantages, okay, features. We'll see the twisted pair cable, first one. Okay, here it consists of two insulated copper wire. Please remember, two insulated copper wires twisted around each other, isn't it? So here what will happen, so these type of cables, so we can generally see in our homes itself, isn't it? If you observe this fans or maybe bulbs, okay, when they are going to connect, no, there are so two colors, like two different colors with a red and yellow, or some different colors, black and yellow, like this. There are two different colors, wires are insulated, that is a copper wire insulated with a material, and those are going to be twisted with each other, isn't it? Those are the using for data transmission, and we can transmit 1 Mbps over a short distance, that is less than 100 meters. So with the speed of 1 Mbps per second, we can able to transfer the data by using such a kind of twisted pair cables, and use it for transmitting the electrical signals, isn't it? So obviously when we are using for those cables for lights and fans, all the things, means it is nothing but we are transmitting the electrical signals, isn't it? Twisted pair is used in telephone networks and LANs. Okay, so twisted pair used in telephone networks as well as LANs. LAN means local area networks, and this twisted pair are mainly used for low cost, low performance applications, isn't it? We are having so many applications out there. Okay, so whenever user is going to be used low cost applications or low performance applications, for that there is not required to spend huge amount for transmission of signals or data, isn't it? So at that time they can opt this twisted pair cable, right, isn't it? That will be the enough for their requirements. And this is example here, twisted pair how look like, so like this. So this is the white and green is there, no? So this is a copper wire is there here. This copper wire is insulated with this material, okay, and with this it's going to be transmit the data, right? So next is this is a shielded twisted pair cable. Here all these are wires are there, no? All are again shielded with some other materials. Okay, so these are the twisted pair cables, and this is a foil shield, and this will be the barrier or a foil shield again. This is we can call it as a jacket for complete wires, right? So this is a representation how the wire look like, isn't it, right? And what are the advantages and disadvantages of twisted pair cable? We'll see. So when coming to the advantages, so it can be used for both analog and digital transmission, right? So it can be used for both analog and digital transmission. It support both types, right? And least expensive for short distance. Right? That means whenever the data transmission is going to be taken place with a very limited range. So within maybe you can say that within the building or within the room, Okay, at that time, so this type of cables are much enough to transmit the data or signals, right? And what are the disadvantages of this type of transmission medium? Means a signal cannot travel long distance without repeaters, right? So we said that when we are going to transmit the data within short range, then we can use it. But the disadvantage is, so when we are trying to transmit the data from long distance, then we cannot, this type of cables are cannot able to support, right? So if we are using these cables to transmit the data from longer distance, definitely we need to use the repeaters. Without repeaters, we cannot able to transmit the data successfully when implemented in long distance, right? So then what is repeaters? Repeaters is a device which are used to regenerate the signal. That means, for example, this is source and this is destination. Okay, assume that for every certain distance we have to install the repeaters here. Okay, so when the signal strength in the starting point is, assume that 10 edges. Okay, the signal strength is 10 edges the starting point. When it reaches to this point, the signal strength is 5 edges. Okay, again without repeater, when it reaches here, the 0 edges are going to be then the signal is going to be lost. That means the data is going to lost. So when I add repeater here, again the repeater is going to regenerate the signal. Again it just boosts the signal, and again now the signal strength is again 10 hertz here. Again it travel here, again it will be the 5 hertz here. So again the repeater will regenerate the signal, and again make it into 10 hertz. Again it is going to transfer, right? So when it reaches without any data lost, the data or signal is going to be reached to the destination. Okay, so that is the purpose of repeaters, right? Next, another disadvantage is high error rate for distance greater than 100 meters. Okay, because I said no, so the signal strength is going to be become poor when the distance is going to be high. Okay, so what is the distance given here? 100 meters. When it the signal is going to be transferred more than 100 meters, the automatically the signal is going to be lost. Okay, that's why when it reaches more than 100 meters, the error rate is going to be high. That means number of lost signals or number of lost data packets are going to be high when the data range is more than the distance is more than the 100 meters, right? Very thin and hence break easily, isn't it? So we know that, so in the twisted pair, I hope that everybody are much aware of these kind of cables. The copper wires are very thin. That means very small in size, so easily breakable, isn't it? So that is a one disadvantage, and not suitable for broadband connection. Right? So whereas in broadband connection means the copper wire must be very thick in size. If it will be very thin in size, means the data transmission speed is little bit poor, and it is not it doesn't have a strength, right? That is the major disadvantage here. It comes under the coaxial cable. So the second one, coaxial cable. So it contains very thick copper. So whereas in the earlier one, it has a very thin copper, but whereas in coaxial cable, it is a thick copper wire we are using in this coaxial cable, and it carries the signal high frequency range than the twisted pair cable. Okay, so it's a comparatively we can easy to remember when compared to the twisted pair. It is going to generate have a higher frequency. That means the copper wire is very thick in size when compared to the twisted pair. So obviously it can have a better efficiency than the twisted pair, and used to transmit both analog and digital signals same as to the twisted pair, and used in LAN and television distribution. So even twisted pair used in LAN, but for the television distribution we cannot able to use this twisted pair because it require higher frequency. Okay, and this particular coaxial cable having a thick in size copper, no? So that is the reason we can implement this in television distribution too, and use it for longer distance at higher data rates. So we can use it this cable for longer distance also. There is no issues, and the applications of coaxial cable are TV software and traditional Ethernet lines. Okay, so even the cable in our homes, generally we are having a dish TV, no, dish or whatever, we can say that some other normal cable TV is there, no. So there itself, if you observe this cable, no, so it should be like this, black in color, the cable, black or white color, it's coming generally, and this will be the shield will be there, coated shield will be there. Again, a very thick white color coating is there. It's a very little bit stronger, and this is a dielectric, and this is called copper wire. Okay, so that will be copper wire will be very thick, very thick. Okay, and this is a inner conductor, we can say that. With this copper wire only, the data or signals are going to be transmitted. So just because of thickness, we can able to transmit the data, that means audio or video, without any processing or without any distortion. It's continuously, the data is going to be streaming easily, isn't it? That's why it supports a high data rate, right? Advantages of coaxial cable are high bandwidth, so better noise immunity, easy to install and expand, and inexpensive. This is not much cost. This is also a little bit cheaper only. But when compared to the twisted pair, it will be the little bit expensive, but overall it is also inexpensive only, right? Easy to install and expand. And the disadvantage is signal cable failure can disturb the entire network. That means once the cable is failed, that means if the cable or signal is going to be failed, so it disturb the entire network. That is only the drawback. The next important is optical fiber. Okay, and obviously when we can compare to the previous one, when compared to twisted pair, coaxial cable provide the better efficiency and good improvement in for data transmission, all the things. And optical fiber, obviously it is going to provide a better efficiency than the coaxial cable. And this is made up of ultra thin fiber of glass. When we use instead of here we have a core is there, no, core cladding is there, no. So always, so when compared with the thick copper, if you use this fiber of glass, means the data transmission speed is much faster than the coaxial cable in this fiber optics. Okay, and information is sent on optical fibers in the form of light pulses, so which when detected generate electric pulses, right? It's going to send an optical fiber in the form of light pulses. Okay, how the data is going to be transferred here means the data or signals are going to be converted into light pulses, and these light pulses are going to be transferred from one source to destination path. Okay, which generate the electrical pulses. And fiber optic can be used for LAN as well as for long distance transmission. Okay, so we can use it in LAN as well as whenever the data we plan to transmit to the long distance, so we can use this fiber optics will be the one of the best option. And the data rate is 2 Gbps. Please remember the data rates. Okay, and what is the data rate for earlier ones? Okay, and what is the data rate for fiber optics? You please just comparatively, you just try to remember. That is very important. Okay, data rate here optical fiber optical is 2 gigabyte per seconds, and it is costliest one, and it provides a higher bandwidth. Okay, higher bandwidth means the data rate it won't take much time for streaming the data even for the long distances, right? Advantages and disadvantages of fiber optics are, so advantages coming here, the increased capacity and bandwidth and lightweight and less signal attenuation, right? And disadvantages are difficult to install and maintain and high cost and unidirection. Unidirection means we'll need another fiber if we need bidirectional communication, right? That means, so one particular cable allows only one-way transmission. Either it is going to be send means only sending. If any another signal is coming in the opposite direction, the both signals are going to be collide and the signal is going to be lost, right? So if we want bidirectional communication, we have to use two cables. For one is for sending, another one is for receiving, right? So that is one disadvantage. Because why I'm make it into disadvantage means so this is a very high cost and difficult to install and maintain. In that particular scenario, if one is difficult to maintain, if we use two cables means obviously the cost is very high, but the performance is excellent because it support higher bandwidth, okay, and the data range is 2 GB per second, okay. So that's why there is a, I told you now, for each and every particular type they have its own advantages and disadvantages. Next, we will see the unguided transmission medium. So this unguided transmission medium, in this, the transmitted the data travels through free space in form of electromagnetic signal. Right here, how what will happen in the earlier guided? There is a one dedicated path is there. Through this dedicated path, data is going to be transmitted from one particular source to destination system, isn't it? Whereas here it's a travel data there is no dedicated path here, so the packets are going to be freely travel across the internet. And how it is going to transfer means, so in the form of electromagnetic signals. So for example, radio waves, infrared are the best example. So here the air act as a medium, so the signals are how the signals are going to be transferred in the form of radio waves or infrared. The data is or signals are going to be transmitted. For example, radio waves. So the transmission of data using radio frequency is called radio wave transmission. Clear? That means, so if the data is transferred through the medium called air, so one is radio waves, right? So this is a radio wave transmission. And we all are familiar with radio channels that broadcast entertainment programs, isn't it? So generally everybody aware of these radios, isn't it? So there is no dedicated wire or any path is there. When we switch on the radio button, so it just gives us some entertainment programs. We can call it as a FM radio. There are some different stations out there. So when we change from one station to another station, we can get the different entertainment programs are coming, isn't it? So this can be the data. What is the voice is coming from our device? How the voice is coming from our device means through this radio waves. It's going to be our device is going to receive those radio waves and it will generate the voice. Okay, just converted into those signal into voice form, right? Radio stations transmit radio waves using transmitters which are received by the receiver installed in our device, right? How this is actually happen means, the radio stations are there, these radio stations are transmit the radio waves, okay. It just transmit the radio waves in the air, okay, and this is going to be travel in the air. And the receiver devices are like our mobile phones or radios are there directly. A device called radio is there. So there the receivers are installed in our devices. The receiver will able to get those waves which is released by the radio stations. Those will be taken and converted into voice and it will be coming through the speakers, okay. And this range usually 10 miles. That means one radio station is there means, so surrounding 10 miles all the radio waves are going to be spreaded, right? The frequency range is 3 kilohertz to 1 gigahertz. 3 kilohertz to 1 gigahertz. Please remember this radio frequency range, right? And radio frequencies can also be used for direct voice communication with the allocated range, okay. This is also possible. Direct voice communication is also possible here, but within the allocated range, within the dedicated range, it is possible to a direct voice communication is also possible with this radio waves. And advantages are inexpensive mode of information exchange. For radio wave transmission, it won't cost much expensive, right? And installation and maintenance of device is cheaper. Okay, with the very less cost itself, we can install and we can easily maintain this type of method. Okay, and the disadvantages are insecure communication. That means if we are generally we are going to a very unsecure and formal things we can able to use. That means based upon the application we are using, it is going to be depend. If it is not a confidential or important things, means we can able to do this one. We can implement with the help of radio waves. We can able to implement and transfer the data. And next is prone to weather changes like rain, thunderstorms, etc. Okay, that is a little bit drawback. It's everybody facing nowadays, isn't it? So assume that we are listening FM radio. Okay, if due to some weather conditions, if any rain will coming or thunderstorms are coming, then what will happen? The radio signals are going to be continuously breaking. We cannot able to hear exactly what they are going to say, isn't it? So those are the some disadvantages are there. Next, we'll see the microwaves. The microwaves, it's this kind of microwave signals are sending and receiving antennas needed to be properly aligned with each other. Okay, so earlier how we are going to see the, for example, a Doordarshan TV is there, no? So how we are getting means there is no, it's we are not at all paying anything to any cable operators for this one. So when we have an antenna, we can fix it in our home in the top floor, the topper or terrace. There itself it can able to take the microwave signals in the air, and then it is going to be converted and into coming a picture in our TV, isn't it? That is going to be happen in the olden days, right? So this distance covered by the signal is directly proportional to the height of the antenna. That means so sometimes what happens, sometimes we are getting distractions, some disturbances are coming. So that means if the antenna is not properly arranged, or any some heavy, like any weather, due to some sort of weather conditions, weather distortions, sometimes it's not coming good. And sometimes if our house is middle one and both our side houses are very tall, then means what will happen? So even the signal cannot able to grasp properly. Okay, that's why always antenna should be in very top in position, then only the signal can easily can take it, and it can able to grasp the signal, and it can the signals are converted into video and audio and again coming into the TV, isn't it? Those frequency ranges are 1 gigahertz to 300 gigahertz. These are majorly used for mobile phones, communication and television distribution. This is an example. If you observe in this figure, the microwave, so links are like this. Okay, these are the medium is here, medium is air. From the satellites itself, it is going to be transmitting the signals. Okay, and this is the one station, station 1, station N. Okay, like means so different stations are directly communicating with the satellite here, right? And data transmission also coming from here to here, and from satellite to another stations are going to be taking, right? And the next important is infrared. This is very simple and interesting. This infrared is a low frequency infrared waves are used for very short distance communication like TV remote, wireless speakers, automatic doors, and handheld devices, etc. Right? So these infrared having it's a very good, better and best communicating devices, but the thing is it can be implemented possible in very short distances only. That's why it will be implemented in TV remote, isn't it? So we have a TV and there is a remote is there, okay, and there is no dedicated path from TV to remote is there. So just with the help of infrared waves, we can able to increase the volume or decrease the volume. We can change the program. Okay, we have multiple options in the TV now, so we can do all the things with the help of remote, with the help of these infrared waves only, right? even wireless speakers, okay, automatic doors, okay. So all these things can be worked with the help of this infrared waves. And infrared signals can propagate within a room, but cannot penetrate the walls. That means, see, even radio signals are very strong and very strengthy, so even it can penetrate the walls and it can reach to the devices. But when, if you observe the remote, if you, otherwise you can just try, if you just increase the volume of your TV with the help of remote, and again if you just put an object between your TV and remote, again you try, so the infrared waves cannot penetrate the objects or walls, okay. That is a little bit drawback. And the frequency range is 300 gigahertz to 400 THz, okay. And however, due to such short range, it is considered to be one of the most secure transmission mode, right. So even though it is works in very short distance range, but this is a very secure transmission mode. This is the best example. So generally we are much aware of this kind of infrared signals in the TVs, generally in the regular life we are using, right. Thank you so much. So today we'll discuss about the different types of guided media, that is guided and unguided transmission medias we are going to discuss, and various subtypes of subdivided, no, guided again 3 types, unguided again 3 types. Each and every one we have discussed, each and every one having its own advantages and disadvantages based on the user requirements. So whether it will be made a cost, or it may be installation, or easy to install, easy to maintain. So based on the requirements, the user is going to implement such a kind of transmission medium for transferring the data or signals from source to destination. Thank you so much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.